So viewers, today our topic is the settling or damping error for the gyro compass. Guys, today our topic is the damping or settling error for the gyro compass, and this is a very important question for the class 2 1 deck preparatory for the DG. So you have to know this one, guys. Okay, for the written exam and also for the oral exam also you have to know. And there are 5 errors for the gyro compass. You know that one is settling or damping error, number 2 is latitude, course or speed error, number 3 is change of latitude, course or speed error, number 4 is ballistic deflection, number 5 is rolling error. So rolling error has two part, like first rolling and second rolling. We will discuss easy all the error, guys. Okay, so first one is the damping or settling error. Guys, after the gravity control and damping control, your free gyroscope is settled in a point, this point in the northern hemisphere, and this point in the southern hemisphere. Guys, you know that in this settling point the drift and tilt is balanced by PC and PD factor, you know that. So as the latitude increase, your settling point also will go to like this way. You can see because of latitude increase, so your earth rotation also increase, so drift increase, so drift increase, tilt also increase, drift increase, tilt also increase. Okay, so in the northern hemisphere the settling point will be in this quadrant, remember. Okay, and for the southern hemisphere the settling point will be in this quadrant, like southwest quadrant. Okay, so this is the equator, this is the meridian. So in northern hemisphere it will be above the equator and east of the meridian, remember. Okay, and in the southern hemisphere this will be down of the equator and west of the meridian. Okay, so the amount of degree it is to the east or west of the meridian, this amount of degree is called the damping or settling error. Guys, this is the definition of the damping or settling error, that after the gravity and the damping control, the settling point is not settled on the meridian. You can see here, it's not settled on the meridian, it is going far and far. Okay, as the latitude increase, it is going far and far. So after the gravity and damping control, this is not settling on the meridian. This is above the horizontal in the northern hemisphere and below the horizontal in the southern hemisphere, and east of the meridian in the northern hemisphere and west of the meridian in the southern hemisphere. So you can see this, the amount of degree, it is east or west of the meridian, this amount of degree is called the damping or settling error, remember. So this amount of degree is depends on the latitude, because as the latitude increase, your settling point is going like this way. You can see, so as the latitude increase, settling point is going this way. So this is the degree, amount of degree is called the settling or damping error, guys. Okay, guys, for the southern hemisphere also same, guys, like in the settling point is west of the meridian and below the horizontal, the amount of degree it is east or west of the meridian, like this is the amount of degree, this is west of the meridian, this amount of degree is called the settling or damping error, guys. Okay, guys, this damping error increase with the latitude, guys. So the drift increase, PC also increase, correct? So from figure you can see this one, that settling point shift with the latitude, so shift with the latitude because of drift increase. So if the drift increase, PC also increase. Guys, you can see the settling point is increasing with the latitude, so drift increase because of the earth rotation is increased, so drift increase. So if the drift increase, the balance for drift is the PC vector is also increased. And guys, you know that as the drift increase, the tilt is also increased. So if the tilt increase, the balance for tilt, that is the PD vector, is also increased. So that's why this is not on the meridian, also is go further away from the meridian, east or west. Okay, and this is also one question, that why the settling point is not on the meridian, that I will discuss in separate video also, no problem. The main reason is for the earth rotation, guys. And you know that, guys, about 75 degree north latitude, beyond 75 degree north or south latitude, the gyro is unreliable because of the drift rate is too much, so that cannot be balanced by the PC. So you know that, that's why the higher latitude the gyro compass is unreliable. So I think you understand the damping or settling error. This is the amount of degree east or west of the meridian, the settling point. The settling point, the amount of degree from east or west of the meridian is called the damping or settling error. Viewers, you can see there is one question for navigate for DG set, like describe settling or damping error and explain why this error changes with change of latitude. This is the figure you have to draw and you have to explain like this. The main reason is the earth rotation. Guys, with the latitude increase, the earth rotation is also increase. We know that, guys. And if the earth rotation increase, the drift rate is increase. So as the drift rate is increased, so settling point is shifted more easterly in the northern hemisphere, more westerly in the southern hemisphere. So drift increase, so tilt increase. So this will be the track of the settling point, guys. The main reason is the earth rotation increase and drift rate increase. So for compensating the drift rate, you have to apply the more and balanced PC vector, and since the tilt also increase, we have to apply the PD vector. So the settling point will be here, where the 4 vector will be equal or balanced like this. Okay. And guys, error means this one, like here error is less, here error is more, here error is more, here error is more and more, means settling point is increasing this way, so error is also increasing. You can see here settling point is increasing this way, so error is also increasing. So this is the answer, guys. If you explain this damping or settling error, you have to explain the compensation method. Guys, remember, in ANSYS Gyro there is no compensation method. Okay, in ANSYS Gyro there is no compensation method. Okay, but for the Sphere Gyro has the compensation method. For Sphere Gyro, you can see I write here also, for Sphere Gyro need to input the manually and automatically the latitude. Okay, remember, and you know that when with the latitude increase, we also input the latitude manually, and also we check also, guys. In my practical experience, I check that the latitude is taking from that GPS or not automatically, because this is interconnected, automatically taken. But if not automatically taken, you have to put manually. Okay, so it is taken automatically or manually, the latitude. So torque motor is inside the gyro compass, which will produce sufficient and opposite torque to compensate the drift and bring back the settling point on the meridian. So this settling point will be come on the meridian, guys, after this torque motor. So that torque motor work as the latitude, work as per the latitude, guys. Okay, so as the latitude increase, the torque motor will produce more torque to bring your settling point on the meridian, guys, remember. Okay, so this is the torque motor to compensate the drift and bring back settling point on the meridian. This is on the meridian. Okay, your settling point now on the meridian. Okay, remember, guys. So torque motor calculate the torque as per latitude that produce increase, maybe 5-degree latitude interval you have to put manually, or you have to check that latitude is taken automatically or not. Okay, guys, you can see in this figure, settling point is on the meridian now. Okay, and drift is balanced by the PC. This is the drift is balanced by the PC, and this torque motor produce the precision that will balance the damping precision, PD. Okay, this torque motor is only on the Sphere Gyro. Okay, but in ANSYS Gyro there is no torque motor, so in ANSYS Gyro automatically it will come on the meridian. Okay, so compensation is only for the Sphere Gyro. I think you understand this one, and you can check. I also write in my language in very simple way. You can also take this note. This is very simple. This damping and settling error is the amount of degree it is settled east of the meridian or west of the meridian. This amount of degree is called the damping or settling error, guys, because this is due to the earth rotation. With the latitude increase, drift increase, so tilt also increase. So this is the track of the settling point. Okay, in northern hemisphere, in southern hemisphere. So normally in the Sphere Gyro there is a torque motor is there inside the gyro compass, and that torque motor is worked for the latitude. So if latitude is taken manually or automatically, as per the latitude, the torque motor will produce the torque, generated torque, artificial torque, that will bring back your settling point on the meridian. So on the meridian, your torque motor produce a torque that is balanced the PD, and drift is balanced by PC. So your this settling point come on the meridian. But in answers gyro, there is no torque motor, it will come automatically. So I think you can understand this damping and settling error, guys.